both the Giesen website and the Boot Coffee website.
Yeah, so this session is being recorded as of now, so everything you say is on the record. But we are a small family here, and everything that we say stays between us. So I'm just going to get ready to put my presentation into the background. Marcus and I, we always have a lot of fun putting these presentations together for these sessions, because it helps us also to kind of refresh our own concepts of how we perceive. In this case, we're going to talk a fair bit about roast profiling, and how it helps us also to recalibrate how we look at roasting defects, which is one of the topics for today. But the key, I would say the key lesson that you will learn today is how to strategize the development of your profiles, and how to build profiles from scratch. Whether you're doing this with the Giesen profiler software, or that you're doing this without any sophisticated software, so using good old pen and paper. So from that perspective, there are, of course, various options available in the world of coffee. As I mentioned, Giesen has a wonderful software, the Giesen profiler software. And there are also other solutions, like Cropster has excellent software. Artisan has software that is kind of free. The difference between the Giesen software versus the others is that with the Giesen software, you can basically not only record your profiles, but you can also manipulate these profiles and then allow them to replay what you accomplished before. And that's a feature that is, I think, really, really important. Today, we're going to help you understand how that works. Also, Marcus has been preparing this session with a profile that has been recorded. And now let's see, let me share my screen. So you should be able to see right now my screen, which says Giesen Webinar. Marcus comes through. Okay, perfect.
Great.
And as always, feel free to ask questions. Use this webinar to your benefit. So let's dive into this topic of coffee roasting profiles and the sensory milestones. After this topic about sensory milestones, we will actually start looking at how to construct, how to develop profiles from scratch. Then we will be looking at some examples of defects as well, roasting defects, and we will have a live demonstration of some roasting with the one of our Giesen machines here at Boot Coffee Campus, and also using the Giesen profiler software. And then feel free to post your Q&A, your questions and answers as they come up. There is this major emphasis nowadays on using digital tools to control roasting profiles. And I would like to highlight or emphasize that obviously these tools are very helpful, very important. And at the same time, it is good to have a understanding with and to be connected with the actual sensory milestones that occur during the roasting of your coffee. And what if, let's say, the software that you're using, what if it fails for whatever reason? That's very unlikely in the case of Giesen software, but what if the computer fails that this software is hosted on? What if you're thrown back to roasting manually? What if you're roasting a coffee you've never encountered before, and now you're put up the task to develop a profile for this coffee? And in those cases, you really want to go back to basics and understand the dynamics of that coffee, how it responds to heat input and air throughput. And you want to build from your sensory information, you want to then build your profile. And sensory information includes what we see, what we smell, what we hear as well, and those three aspects are helpful in coffee. So when for this case study where I'm using these photos, we're looking at some washed coffee. This is the product that we start out with for this purpose. The origin of this coffee, it's like an Ethiopian washed coffee, Sidama grade coffee. And when we are starting the profile for this case story, when we're going through our sensory milestones between the moment of charging the beans to this point where we start smelling like this freshly cut grass, 272 degrees Fahrenheit at this point. Maybe Marcus, could you convert that into C for those that are not in the US? So at 4 minutes, 10 seconds, this is the milestone we smelt at this in this case study. So what actually has been going on between here and here is that upon charging the beans gradually start absorbing heat at the point that the internal temperature of the beans exceeds the temperature at which water boils. That temperature in Fahrenheit is 212 degrees. In Celsius, it's 100 degrees, the water boiling temperature. At that point, the water vapor that starts developing now induces the first stage, the first phase of the chemical transformations in the bean. Water vapor starts building up pressure, and that pressure buildup starts to induce the Maillard reactions. That are reactions that, as you might have learned from our previous sessions, or that you can learn at one of our ongoing webinars that we host at Boot Coffee. These Maillard reactions are at the core of what we ultimately will be able to perceive as coffee flavors and coffee aromas. They're very complex. So this freshly cut grass smell, which starts actually a bit before this point that we indicate in the photos, is very noticeable at this stage, where we are looking at a bean temperature approximately of 272 Fahrenheit. Marcus, what is the Celsius conversion?
Yeah, I typed that into the chat for everyone too. It's about 133, 134 Celsius.
Yeah. And at this point of 300 degrees Fahrenheit, now we are at 5.5 minutes. Now we smell like this hay smell. This is indicative for an ongoing development of the Maillard reactions. And this, you can also see that the beans start changing color. The browning of the beans occurs. This is the very, very early start of where we talk about the caramelization occurring. And as you might know, coffee has a complex set of sugars, and the caramelization is indicative for the fact that these sugars start transforming. Then we continue we're now at 354 degrees Fahrenheit, 7 minutes, 50 seconds in this specific case study. We're getting to this A point, which is before the first crack. It's the precursor of the first crack. It's the point where internally in the beans, oils start becoming volatile, and for a brief phase, there is actual coffee aroma can be perceived, and that's the A for aroma, the aroma point. And that's a precursor for the first crack. At this stage, we see an early beginning of what we call the exothermic reaction. So this is where heat that is locked into the cellular structure of the coffee starts to come out. The beans now actually start helping in the generation of heat during the roasting process. Then in this specific case study, at 387 degrees, first crack almost finished, 10 minutes, 15 seconds. Marcus, could you look up the equivalent of 387? Or maybe you've already been posting those. Yeah.
Celsius. I'm just typing all of these into the chat for everybody.
Yeah, so look in the chat box for the conversions. So first crack almost finished. Now we are obviously well into what we call the roast development, into the development cycle. The development cycle starts at the early onset of the first crack and continues until you finish your roast. And you can see color changes. We are smelling now at this stage distinct coffee aroma. And then this specific roast was finished at 393 degrees Fahrenheit at 11 minutes, 20 seconds. So that's kind of sets the stage for our discussion. And I think, there's a practice you can do in your own roastery for training purposes that's really great, where you at intermittent intervals, at milestones similar as what we indicate here, that you take out small samples of your coffee being roasted, lay them out on a sheet, indicate the time and temperature points, and that's a great learning tool by itself. And we're showing you a graph that kind of over accentuates the different milestones. For example, the roast development time indicating here is not something that I would recommend you to do, because it would for sure lead to, with such a long roast development time, to overdeveloped or even over roasted or even burnt beans. But here we over accentuated the milestones in the cycle of roasting. So you can see that point of freshly cut grass, the point of hay, the point of baking bread, and the point where the first crack occurs. And then the roast development time leading to the end. The red curve is the bean temperature curve, and the other curve is the air temperature curve. You can also see the point where exothermic heat starts developing. And then this specific graph, which would be indicative for someone who takes a coffee to a second crack, which is nowadays not that popular, but still companies do this. You can see that there is actually a second stage where exothermic heat starts developing. And Marcus will now lead you to the approach of creating profiles from scratch. Marcus, you've got the podium.
Yeah, thanks, Willem. Yeah, I'm glad that you said that that was a second crack profile, because the development time and the development percentage there was close to 30%, which, may not be out of the ordinary for a very dark coffee. And just one other question came through from Roy Lowe in Vietnam, asking if the temperatures were from a 1 kg machine or a 6 kg machine. The temperatures, Roy, that we're talking about here are the temperatures where these actual chemical reactions begin happening. In your machines, the temperatures might be quite different. These temperatures that Willem was referring to fall kind of in the middle of where our readings fall on our W1A and versus our W6A. So I think, one of the reasons why it is so important to really have a strong understanding of these sensory milestones is because they help you to understand your machine and where these events are happening. So I hope that answers your question, Roy.
Marcus, do you want to take control the presentation on your end?
Yeah, that sounds great.
Yeah.
I don't have it open though, so maybe since it was a shared presentation, maybe.
Shall I continue controlling it on my end?
Why don't you just control it on your end?
Okay, perfect. Very good. Okay. And play. Yeah, perfect.
So with Willem's intro there, I think, we're going to actually talk a little bit about data and numbers, both with the respect to timing, but also with respect to temperatures. But again, these temperatures are really more applicable just to your roaster. And really it's about watching the coffee first, and then the data kind of equally important. But where do you start, right? I mean, it's oftentimes we're presented with a brand new coffee. We've only sample roasted it. We aren't quite sure where the sweet spot is going to be, or maybe a reference profile that we're using produces a coffee that's a little bit too harsh with sharp acidity, and you want a more balanced sweetness. So, from there, I think it's worth having some tools up your sleeve to think about what is a well-crafted profile that is likely to be kind of sweet and balanced. So go ahead, Willem, to the next slide. And and I think to achieve that, there's a couple of concepts that it can be helpful to understand. Now, I performed a roast this morning using a concept that I really do believe in, which is the midpoint temperature. And this midpoint, it simply refers to on your roaster for kind of typical coffees, what is the temperature in the middle of your first crack temperature and your second crack temperature? And with a couple of trial roasts that I did this morning, one with a washed Colombian, kind of a blend, and one with a washed Pacamara, I was hitting first crack at about 390 degrees Fahrenheit, second crack at about 425 Fahrenheit. So if I just take the difference between those and find the middle temperature, my roaster roasts to a midpoint temperature at about between 407 and 408 degrees Fahrenheit. Maybe Willem can return the favor with conversions for some of these. But why does midpoint matter, right? I think it matters for a few reasons. One, if you're just not sure where to roast a coffee, this usually represents, kind of with adequate development time, a point in the roast that will be kind of a medium roast color, enough of those browning reactions, the Maillard reaction and caramelization have occurred to create a sweet cup, while also maintaining adequate acidity. Even if you're roasting lighter than midpoint or darker than midpoint, it can just be a useful reference to have as you're watching your rate of rise between first crack and second crack, because color changes and aromatic changes do happen quite quickly as you're moving through the development phase, and knowing where your midpoint is relative to your final target temperature and color can be quite helpful. So that's why the two reasons why I think midpoint temperature is really important to understand for your roaster. So even if you never roast a second crack, maybe it's time to sacrifice a batch of coffee and figure out your midpoint temperature for a typical batch size. So go ahead, Willem, to the next slide. And then I think, another sort of key component of the roast that we already have begun talking about is this idea of development time. And development time is just the time from the first crack until the end of your roast. And often we express this as a percentage. So what's the percentage of time from first crack to the end of your roast? And there have been others that have written about ideal development time percentages and target development time percentages. But really the key to this is there is no golden key on development percent. It partially depends on the coffee you're roasting and your goals. But a general rule would be that the darker you're roasting, the longer your development times would be. So a coffee that's approaching or has reached first or has reached second crack might very easily have a development time in the range of 20 to 25% for a darker roast. I think medium roast coffees, a reasonable development time is probably somewhere in the 16 to 18%, and very light roast coffees might be more in the 14 or 15% development time. But ultimately, it's cupping at the cupping table and deciding what tastes good to you. Go ahead, Willem. And how do you calculate this? I mean, it's pretty straightforward. If your numbers are nice, like in this example, it's just the time from first crack to the end. So 10:35 to 2:45 is 2 minutes and 10 seconds. But often, and especially when you get to expressing this as a percentage of the total roast, if you're not using a profiler like the Giesen profiler or some of the other tools, you need to do it manually. And the best way to do that is to convert everything to seconds. So just multiplying the minutes by 60 and then adding the seconds gives you that formula. And then to create that into a development time percentage, it's simply dividing, you can go to the next slide, Willem. It's simply dividing that period of time in development by the total roast time, multiplying that by 100. And in this example, we see that this coffee had about a 17% development percentage. Now, why does all this matter, right? I'm always curious when I make statements like this to see if Willem agrees or disagrees with me. This is part of what's fun for these for us. But I would say from sort of a consumer standpoint, from a quality control standpoint, batch to batch matching the end color of the ground coffee is kind of the best meta indicator that coffee is going to taste fairly similar to previous batches, especially if your weight loss percent is kind of in line. Second to that, I would say that it's development percentage of your total roast. That is really important to nail in order for consistency, right? So that means if, say, my reference profile calls for me to hit first crack at 10 minutes and end of the roast at 12, and I step up to the roaster and maybe things are a little bit hotter and I hit first crack at 9 minutes, well, I'm going to try to match that end color for my reference profile, and I'm going to try to match my development time as a percentage of my total roast. And I bet if you do both of those things, that coffee will be virtually indistinguishable from your target. I don't know. What do you think, Willem?
Yeah, I agree with that. At the same time, of course, that doesn't exclude the possibility that, let's say, air pressure could be different in this scenario versus other scenarios where you're roasting, and air pressure changes can occur easily, especially, let's say, if a roasting machine has been operating for a number of hours, then the air throughput through a machine, because there's more chaff and more debris, that can change the heat transfer quite dramatically. So I guess, but as a general approach, I think absolutely that should work really well.
Yeah, of course. There's lots of, there's everything matters ultimately, but kind of from that meta perspective, I think it's really important. So, here on the next slide, I actually performed a roast to my midpoint temperature, which was 408 degrees. I went ahead and recorded that, and also attempted to target about 16 or 17% development, which I did. So I don't know, we don't have to watch the entire recording, but here you can see my Giesen profiler active. And Willem, maybe we should just skip to like the 4-minute mark just to get us some good data.
I'll just gradually go through this.
Yeah, so you can see, I'm following my profile as far as my gas inputs.
You want to comment what's going on now? Because the bean temperature now, instead of going down, it starts going up, right?
Yep. So this is kind of the first data milestone because it gives me my 0 point for tracking my rate of rise. It's the turning point. It's where the temperature of my thermometers and my roaster have stopped showing a decrease in temperature and are now showing an increase.
And you can see that rate of rise curve now in this accelerated replay starts to create a curve. It's reached a peak at I cannot see because my screen is covered with all kinds of the peak of the rate of rise was where?
Yeah, it was about 30 degrees Fahrenheit per 30 seconds, which, to go from 140 degrees Fahrenheit at about a minute to 390 degrees Fahrenheit at first crack at 9 minutes, that kind of can inform what that rate of rise needs to be. And you can see, for this particular profile, I'm giving it quite a bit of heat early on. I am reducing the heat as I go a little bit before my milestones. Here I'm getting a little flick in my rate of rise, but that was due to my making a change in the way I was handling exhaust emissions on the roaster. So I think it was more noise in the data than anything in the bean. And you can see it gets back to equilibrium quite quickly.
So some folks, when they see a flick like that, they immediately think, oh my God, my roast is ruined. But what do you comment on that?
Yeah, I mean, I think, there are true flicks that are indicative of having a roast that's out of control. I think a flick at this point in the roast, while the coffee's kind of still in that drying phase, kind of at the end of that green grass and just before that hay milestone, is really, it's just noise in the data and I'm not worried about it. I'm still going to cup it and pay attention. But you can see here, indicated at that top of the graph, just before 5 minutes, the set point in the profiler for ending the drying phase and starting the Maillard phase was recorded. But I, through looking at my coffee, decided, what, it was actually a little bit later. It was about 40 seconds later when that color change happened. So I recorded that. That's what that note that I was leaving was, my record of that at about 5.5 minutes. But, now I'm just cranking along. I'm watching my rate of rise. I'm really looking at my coffee and using what I'm observing both in the trier and with my data to make gas adjustments as necessary. So Willa, maybe we can skip forward now to, closer to 8.5 or 9 minutes where I'm expecting first crack. You can see I'm continuing to come down the gas and just to make sure I have enough power to maintain an appropriate rate of rise into first crack. Here you can see I'm really coming off the gas because I was witnessing that A point, that aroma point in my trier. Both the smell of coffee was coming out and the beans were sort of starting to swell and release a little bit of chaff. So I'm very minimal gas to anticipate that exothermic reaction. Here we are at almost 9 minutes. I'm started to hear at about 8:45 the very first outliers of first crack. So, in order to use these sensory milestones to guide your roast, you need to be very consistent with what you consider to be first crack and what you consider to be yellow. So in this case, it wasn't the first couple of beans that I heard, but it's when it was clear that most of the coffee was rolling into this first crack. And now I'm tracking the development time. I'm really watching my coffee. And in this case, it's a coffee that I don't know very well. It's a coffee where I wanted to find the sweet spot for it. I found when I cupped this Pacamara, it had sort of like a sweet, oniony characteristic. So it's a coffee I wanted to develop maybe a little bit more than a cupping roast to try to pull that into sort of an interesting, savory, complex sweetness. So I think that midpoint might be the sweet spot for this coffee. But I'm not relying just on my data. I know that my midpoint is 408 bean temperature, so we can go a little bit forward here, Willem, maybe by 30 seconds or something. But I'm also really, really watching the coffee in my dryer. And these little flips that you can see in the rate of rise here at the end of the roast is often because I'm taking a lot of very short glances at the coffee in my dryer and smelling it. And using that along with what I see in my temperature to be decisive on my end of roast, which is right here at 16% development time, 408 degrees, 409 degrees on the bean temperature. When I measured the color of this coffee using my color meter, it came out at Agtron Gourmet 57. So kind of a classic, really what in my lexicon I would think of as a medium roast. So I'm excited to taste this coffee because I suspect it really is going to be a pretty good starting point. It might not be where I end up with this coffee, but I think it's going to give me some good direction for future roasts and probably be delicious enough that customers and others drinking it will be satisfied.
Cool. Let's move on. And there was a question of Rick Appleton in regards of recognizing the second crack. If you cannot hear the second crack, and I guess the same would be valid towards the first crack. So what's your advice, Marcus? If you cannot hear the cracks, and that's a normal phenomenon because roasting warehouses can be noisy, especially if there's other equipment running. So how do you deal with that?
It's sensory for me. I think for both first crack and second crack, there are distinctive smells. At first crack, it's kind of this instance where the coffee begins to smell more like coffee, less like baking bread. There's kind of like a sharpness to it, like a, kind of like an acid-driven aromatic. That's a pretty good indication that first crack is imminent. Second crack, it's, the coffee kind of gets smokier and smokier from first crack to second crack, especially from midpoint to second crack. But really, when I am getting to second crack, when I see that coffee in the dryer, I can visibly see smoke coming off of it, and it's no longer steam. So those are some good indications for when those events are happening.
And here's a comment from John. The W1A comes with a rate of rise program. So how does an automatic roaster take into accountability for moisture, density, size, and process? So is there a way for software to take aspects into consideration that are important to the roasting? What would you comment on that?
Yeah, I think, and there's another question later on too from Sylvia. She's asking if the coffee is dry, like a moisture of 9. I think as the coffee dries out, the risk, of course, comes into roast defects. First of all, if your roaster's too hot, you're quite likely to scorch the beans, especially as they are drier. So we'll talk about that in a minute. But also, I've found that drier beans sometimes actually take a little bit more heat kind of over a longer period of time. So a moister bean, I might be able to use this approach like we see here, where I hit it with pretty high gas initially. A slightly drier bean, I might give it less gas initially, but maintain that energy over a much longer period of time. Like with a moister bean, I might use yellowing as my first indication to decrease the gas. With a drier bean, I might wait a minute or two after yellowing to give it my gas reduction, because it's a little bit harder, I think, to penetrate into the middle of a dry bean with energy. It doesn't have the benefit of moisture to conduct that energy kind of from the outside to the inside of the coffee bean.
But it's also interesting to notice that when you're roasting with a gas heated roaster, that the flames, the combustion of the gases leads to the production of hydrocarbons as well, which obviously contains a lot of water. So with gas heated roasters, you're also adding back some moisture through your preheated air to your coffee, which is different from when I'm roasting with an electric roaster, right? That would be quite different in terms of dynamics.
Yep, yep. I also see Jean P asked about if we can see the picture of yellow to see the
Yeah.
point of organ, and we can go back to the color. I think it's hard to show on a slideshow. I use my nose as much as I use the color of the beans, but for me, yellow is yellow. There's no more green on that coffee bean. It is fully yellow.
So this photo that you're seeing here, this hay point, the photo doesn't do justice to the color yellow, but this is where you really start seeing shades of yellow, and that will have already started a little bit before this point as shown in this photo.
And I think the other important piece here is that it's yellow, but we also refer to it as hay. So it's the time when I smell that coffee in my dryer, it no longer has any sort of damp or moist or wet grass smell to it, and it smells like fully dried out hay or straw. So I use my nose as much as anything. Um, so maybe I'm a little bit later than some. I've definitely seen some roasters call it when there's still a little bit of green. The SCA has actually studied this at Roasters Guild retreats. They've had a researcher go around and kind of take notes and take samples from different roasters, trying to figure out when we call yellow yellow. Because as we start breaking coffee down into these milestones, we need to have a common language for that.
Maybe that's where I make some comments on this specific slide. I tried to highlight two different approaches for roasting. We often get these questions, how do I roast my Kenyan coffee, or how do I roast this natural process Brazil? So there's a million different options for the roasting of coffee, and it is always to make life for the roasters a bit easier. It's helpful to create categories of types of coffee and then to adjust your roasting strategy accordingly. So one approach is to use your density measurement, and density is basically an expression of mass. So you can use a so-called graduated cylinder to get a good idea of what the density is by filling the graduated cylinder, and to measure the weight of that coffee filled in to a certain point. And that can help you then determine the density of this coffee. And then we talk about softer beans being lower in density and harder beans being harder in density. And here is one approach to roasting softer bean types. And typically, as I mentioned, softer bean types are beans that are grown relatively lower, or it can be beans that have distinct features. That can be, the variety of the coffee can give the coffee specific features. For example, a Pacamara bean is a good example for a softer bean, or Maragogipe beans behave like softer beans. Beans typically grown in the Caribbean areas like Jamaica, Puerto Rico, Dominican, due to their conditions, both on elevation as well as in relative humidity, behave like softer beans as well. So lower charge temperature would be wise. In this graph, we're looking at a coffee that was charged at 350 degrees air temperature. And then less heat leading to the first crack. I think there is a slide indicating this in the next picture. And then you're following still the same sensory milestones, and you're also using the same approach to calculating roast development as Marcus presented before. For a softer bean type, in order to come out with a flavor in the cup that is not underdeveloped or not overdeveloped, typically a roast development time in this example of 1 to 2.5 minutes will set you up for the best success. And then at all times, you really want to ensure a controlled bean development after the first crack, meaning, what does that mean? That your rate of rise is not too high, not higher, definitely after first crack, definitely not higher than 10 degrees. You might want to actually keep it between 3 to 6 to 7 degrees Fahrenheit. And in this example of this roast, we had about 2 minutes of roast development time on a roast that took 12 minutes. And if you calculate that, that's a roast development time of 16.7%. In this specific case, these softer beans were roasted with a Giesen, actually with our Giesen W6A. And we controlled the burner manually, meaning we adjust the percentage setting of the burner. So the BTU percentage is indicative for the output of the burner. And we started at a lower burner setting, charged the beans at 350, then increased the burner to 70%. And then at the stage where we are really into caramelization, this is where the beans really start browning. Then we start to gradually reduce the burner to 35%. And then at the before the onset of the first crack, before the A point, we reduced the burner to 20% to finish this roast. So that was the approach for these softer bean types. And then here we are looking at another curve. Now we are roasting harder bean types. These are beans that are grown higher, they have more density. They're also distinctly from a varietal. It could be a Caturra type of bean, which is a variety that has the propensity to develop denser beans under the same conditions. So now we want to use a higher charge temperature. In this case, we chose 375 degrees with more heat leading to the first crack, which will be shown in the next slide. Following, again, the same sensory milestones. And in this case, since we are aiming at a roast with more heat, since we are looking at a roast that is slightly faster than a softer bean type, a roast development time window of 1 to 1.1 and 1/3 minutes. And then the controlled bean development after the first crack, just like in the case of the previous example. And this is how this heat supply looked like, where we are first immersing the beans with a lower level of heat input, 20%, until the bean temperature starts to come up. And then we increase the burner setting to 90%, so a lot of heat. And then in a profile like this, very important to reduce your heat input on time in order to approach the first crack with a rate of rise that is, again, not exceeding 10 degrees. And then actually in this example, we turned the burner off almost completely, and at some point completely, when the first crack was in full swing, in order to finalize the roast development, and which was in this case 1 minute and 1.5 minutes, 90 seconds, which was a roast development time of 14.6%. And so this gives you two examples of a softer bean versus a harder bean roast profile. And maybe Marcus, you want to jump in on this next section?
Yeah, of course. So, as you're roasting, we do have these really important phases that we need to watch. And, these individual beans might give you a slightly better look at some of these colors that we're talking about. So here's our green coffee bean. And as we progress through the roast, I think this is a fairly nice look at yellow. When I look at this, it is a fully kind of yellow tan bean. I don't see any hints of green really left here. And as we progress, it gets a little bit darker. This is what you might refer to as like cinnamon in roasting. It's kind of the color of like a cinnamon stick. And moving along, you can see as we slice it, it's always interesting to take a look at how the coffee is developing, not just on the outside, but also on the inside. John is asking for a picture of the yellow bean again, if you can go back. And John, I think it's going to be impossible for you to really have a good sense of this with just from photos on a slideshow. I really do recommend, every 15 seconds, pull 4 or 5 beans out of your roaster on the dryer. And, especially if you're curious around this yellow phase, do that maybe from, 4.5 minutes to 6 minutes. And look for that point where there's no more green left in the coffee and the coffee is entirely yellow, and smell the coffee at each point in the dryer as well, and try to pinpoint that time when there's no more grassy smell. So hopefully that helps, John. Go ahead, Willem, to the next slide. And so here, this is really approaching that A point. This is getting just on the cusp of first crack. You can see the coffee has kind of moved into a slightly elastic stage. It's getting ready to swell and expand as that volume increases of your coffee as you roast. And at this point, you can also see, not just the color, but you can start to see the sort of cellular structure inside the coffee bean open up, allowing for that expansion. And as we move along, here we are, like right as first crack is about to begin. Next. And now we are underway with first crack. So, the color is much deeper. You can see the center cut is opened up. The bean has swelled. It's kind of gone from, sort of a hard, waxy material to something that's a little bit wrinkled to something that is now really expanding significantly in size. So moving along to the next one. As we go from first crack to second crack, this is where things can happen fast. Color changes somewhat subtly. That's why it's really important to have data at this point of your roast, I think, but also to understand the smell of your coffee. It continues to swell. Move along to the next slide. As you cut it open, you're starting to see the development on the inside. So it's, you can see clearly starting to develop throughout. The color internally is always going to be lighter if things are going well than externally. Now we're approaching, probably a little bit before the midpoint. So, at this point, first crack has completed, um, and you're just continuing to drive these caramelization and Maillard reactions as you go longer and longer. So here we are. I would say this looks at about the midpoint of the coffee. You can see, again, some deformation from the increase in size. I would imagine at this point in the trier, this coffee has started to really smell like cooking sugars. It starts to smell like caramelized toffee, chocolate kind of notes. And as we go darker and further in our roast, to the next slide.
I think this is the last photo. Oh yeah, here we see the same beans that you just saw, but now from the other side.
Yep. And so, this to me is, represents, kind of a medium, maybe, slightly beyond medium, but nowhere at second crack yet. Example of a roast. So.
And this is where I can maybe jump in because now we are going to talk about how to recognize some of the roasting defects and how to prevent them as well. And so, this is kind of the concluding topic of this session. So obviously we've been trying to help you understand what to do in terms of preparing your profile in such a way that you're preventing defects. But now let's look at some stages where defects are still going to occur. So, this photo, what we're looking at here is basically a bean that shows that water vapor is exiting this bean unevenly from one side of the bean towards the other side. And so this can be indicative for the fact that the initial heat applied to this coffee was just too much for this coffee to handle. So now water vapor leaves the cellular structure of the bean with the path of least resistance. And so if the beans themselves are relatively fresh crop, then it is possible that it is possible that water vapor, moisture starts to exit the beans more in one side of the bean than the other side, which can lead to other problems later on. So the prevention is to treat this specific coffee more like a softer bean, which would prevent the uneven development of the coffee later on. And I have another photo that illustrates this. Here what we can see is the very early stage of scorching. So here we're really looking at some burnt marks around the center cut of the bean. So this is an indicative for a first stage of scorching occurring. Scorching is basically where the exterior surface of the bean slightly burns because of the drum being possibly too hot. So there's hot spots on the drum which allow these beans to get burnt at some spots. This is, of course, a very serious case of scorching. In this case, the beans were clearly, in terms of their makeup, not able to resist the high levels of heat of the drum. This could also be an example where we are roasting coffee in a single wall drum where the flames of the burner touch from the other side the drum, and that heat, that contact heat, leads to somewhat severe problems on the bean itself. The flavors that one can perceive here, could be burnt flavors. Although the ground coffee might not indicate that it was burnt because it might still be within spec, but the flavor profile might indicate that there is a burnt note in the taste, in the flavor profile of the coffee. This is a nice example of tipping. So here we are looking at the side of the bean, also where the embryo of the coffee of the green bean would have been located. And so, here you're looking at beans that for various reasons were rotating within the drum in such a way that the tips were touching the hot spots of the drum. Could be an issue with the roasting drum itself, but it could also be an issue where if you're roasting with a Giesen, which are double wall drums, if you're roasting with a Giesen and you're turning up your RPMs of your drum too high, then you basically develop centrifugal forces, which allows the beans to be pushed more towards the drum itself, which can lead to tipping. This is an interesting one. This was a bean that wanted to get roasted as a softer bean, but it did get treated as a harder bean. As a result, there's kind of a heat shock. The bean is expanding much faster than the structure of the bean allows. And this very quickly, easily leads to a roast profile that can be overdeveloped. So it's not necessarily burnt, but it's overdeveloped. The beans basically kind of are bursting out of their jackets, literally. This is one that is indicative for fractures in the bean that were probably already there pre-roasting. In the roasting process, a small chip pops out of the exterior surface of the bean, and the fiber structure under that chip now starts burning, starts over roasting, and that obviously can lead to specific taints in the cup. There are various possible causes for this to occur. Here we have an example of internal scorching. Remember that very first bean that I showed where water vapor was exiting the bean, kind of in an irregular, inconsistent way. Here we see the potential consequence of that. Look at the left side of the bean being more roasted than the other side. This is a crosscut of a coffee bean. So the left side is that area where more water vapor has been exiting, leading to a higher level of development of that side of the bean versus the other side. And this is a more serious example of this. This can also be indicative for a bean that was just roasted with too much heat for what the bean under normal conditions would be able to handle, leading to this internal scorching. And then here are some examples. Let's assume our target was the bean on the left, our roast target. So then here you can see the gradations of things going wrong, where you have the overdeveloped bean, which is not clearly shown as over roasted or burned. Then we have the over roasted bean, is the color spec is slightly off, and the burnt bean, where now the impact of that on flavor is that there's a clear burnt flavor. And I would like to add to that there are other examples of defects. You can also read about that in the column that Giesen publishes through their Giesen website, giesencoffeeroasters.eu, and where I highlighted all the other types of defects. One is, of course, an underdeveloped bean, which is a bean that is roasted very light with a RD, a roast development percentage less than 10%. That leads to greenish flavors, nutty flavors, raw nuts in the cup. And there's also an interesting defect, which is indicative for growing conditions, which is called the Quaker. It's a bean. I don't have an example of it here in the presentation, but you can Google that, Quaker bean, and you can easily look at that. They show a very white peel in the roasted coffee. And that, my friends around the world, that concludes this webinar. Maybe, Marcus, you have some comments to take home for folks, and maybe comment something about the courses that are coming up, the webinars that we have scheduled.
Yeah, of course. I think, it's have fun with this stuff, right? We present you all with a lot of concepts and suggestions and possible directions to take your coffee. But, at the end of the day, you have to produce something that you really like and that your customers respond well to. So, don't be afraid to sacrifice a little bit of green coffee to some of these trials to really understand what your machine is capable of and what you're capable of as a roaster operator. Relative to the cost of your new Giesen, a couple of bags of coffee is just a drop in the bucket. And if you're interested in taking this a little bit further, we do have some webinars coming up, 3 that kind of cover very different but equally important aspects of coffee. March 11th and 12th. If you're internationally out of the US, the deadline to register for this would be over the weekend. It's our virtual tasting course where all of the students receive a box with numerous coffee samples. We taste them sort of independently in our own labs. We connect via a webinar over 2 days to share notes, to talk about calibration, to really, send you on your path to becoming a better cupper. It's a great prep for the queue if you're thinking of that. We also have a course that takes these ideas that we've been talking about today with roast profiling on March 18th and 19th. It's a webinar, 2 days, 2 hours each day. So a great way to explore these topics in depth. And then at the end of March and the beginning of April, we spread these apart by a week. They're two 4-hour sessions. We get into the nuts and bolts of starting a roasting business. So it'd be cool to see everybody for some of those courses. You can register on bootcoffee.com/webinar. They're quite affordable. So with that, thank you all. Some great questions came through the chat window and the Q&A today.
Great, and I posted the websites, giesencoffeeroasters.eu. You can read, follow all these webinars again. We've done quite a few with our friends at Giesen already. And have a great weekend and a great continuation of this year. The next webinar will be the last Friday of March, and see you then and see you soon. Stay healthy and stay happy, and roast all wonderful coffees, and have fun with that. Bye-bye.
Bye, everyone.